So continuing on with our sinusoidal functions, all right, today we're going to look at this video will look at exploring the actual equation in standard form. All right, here we have y equals a sine bx minus c plus d. The textbook, for some reason in chapter 5, switches from h and k to c and d. We'll continue using h and k. So instead of writing this as a c, all right, you can call that h. It's the horizontal translation. And instead of using a d here, all right, we'll use our k value to represent the vertical translation. So h and k. And don't forget, it could be a cosine curve as well. Now, a represents the vertical stretch. So it's still the same thing. The vertical stretch about the x-axis by a factor of absolute A. If A is a negative, it would be vertically reflected in the x-axis. But little a also tells us about the amplitude. Remember, though, the amplitude is equal to absolute little a. So little a can be a negative. The amplitude would be stated as a positive. The b value, all right, it influences how often the pattern repeats. Okay, so in this particular section, it still represents a horizontal stretch about the y-axis by a factor of 1 over b, but it also shows us how many repetitions we'd see over a 360-degree period. So if the b value is 3, that means the period would be 120, and you'd see 3 repetitions, or 3 cycles, 3 full cycles of the curve. Don't forget, if it is in radians, the period is equal to 2 pi, sorry, the b value is equal to 2 pi divided by p. That also means the following, okay? If b is equal to 360 over p, then p equals, and this was in the last video, 360 divided by b. And over here we can have p equals 2 pi divided by b, just simple formula rearranging, all right? But it influences how often the pattern repeats. Horizontal translation, the h value, again, the textbook, when you get doing questions in there, if it asks for the phase shift, it means the same thing, horizontal translation. Another term, or they throw this term around in chapter 5, the phase shift. And they don't use h, they don't use the variable h, they use c. But it's all good, same thing. If h is a positive, inside the brackets, all right, so this would be in brackets. To take it out, it becomes a negative, so you shift left. If h is a negative inside the brackets, when you bring it out, you still change the sign, just like we did in chapter 1, 2, 7, and 8, and it means you would shift right. Vertical translation, you don't have to change the sign. It influences how far up and down the graph will shift. K value is positive, you shift up. If the K value is negative, you shift down. And it's equal to the sinusoidal axis, all right? So if K, so an example here, if K equals 3, then the sine axis would have an equation of y equals 3. Remember, the sine axis is the horizontal line that cuts the curve in half. So same rules apply as chapter 1, 2, 7, and 8. A, the vertical stretch about the x-axis by a factor of absolute A. If A is a negative, vertically reflected in the x-axis. B represents a horizontal stretch about the y-axis by a factor of 1 over absolute B. If B is a negative, it's reflected in the y-axis. However, these curves just repeat, so you're not even going to be able to tell if it's reflected in the y-axis or not. H value is your horizontal translation. Okay, when you take it out of the brackets, you change the sign. So if a negative in the brackets comes out as a positive, shift right. A positive in the brackets comes out as a negative, shift left. K value is the vertical translation. You would shift K units up if it's a positive, or K units down if it's a negative. Let's look at an example here. Okay, so let's put it in standard form first. So the first thing I would do with this is I would subtract 5 from both sides. 2y equals -6 sine, and then I have 1/3 x minus 30 degrees in the brackets, and this would become -8. -3 minus 5 is -8. Next, I am going to divide by 2. Now remember, you divide every term by 2. Well, this whole thing from the negative sign in front of the 6 to this bracket, that's one term. So I'm actually just going to divide the a value by 2. But this back behind here, the k value, that is another term. Don't divide the b and the h by 2 as well, because then you're dividing this term by a factor of 2 to the third. So you're dividing, it's like dividing that term by 8. So it's really just the a and the k that we're working with. This gives me y equals -6 sine 1/3. Ooh, that's a greasy 3. 1/3 times x minus 30 degrees, close the bracket, minus 4. I did not divide the -6 by 2. That should be a -3. My bad. Okay. Am I done? The answer is no. What can I do to this? If you said factor out a 1/3, you are correct. So I'll factor out a 1/3. So this 1/3 will come out. You open a bracket. Think about this, pretty easy. What's 1/3 x divided by 1/3? Well, it leaves x. However, what's -30 degrees divided by 1/3? Well, that becomes -30 degrees times 3/1, which gives you -90 degrees. So this -30 would actually change to a -90. Close the bracket twice, minus 4. So there is my equation. 1/3 x minus 90 minus 4. Okay, if you're wondering how this 30 became a 90, check it out over here. I divided the -30 by 1/3. Now I can pick out my a value. Little a is -3. That means the amplitude will be +3. My b value, it's what you see in the equation. It's 1/3. Okay, remember how to find the period. The period is equal to, well, it depends on if you're working in degrees or radians. I can tell I'm in degrees because of the horizontal translation. So it becomes 360 divided by my b value divided by 1/3. Remember, dividing by a third is like multiplying by 3. So the period would be 360 times 3, which would be 1080. So what that means is you're only going to see a third of a cycle between 0 and 360. You don't see a full cycle until you get all the way over to 1080 degrees. So between 0 and 1080, you would see that full cycle. And remember, it's a sine curve, all right? So it should start on the sinusoidal axis. Now, because it's reflected in the x-axis, instead of going up, it'll go down, then back up, and then back down. But you'd see one full cycle. This would be 0, whatever. This would be 1080, whatever. The h value, a -90 in the brackets, +90 out. Remember, this is called the phase shift, or the horizontal translation, as we typically call it. -4 is my k value. That means I would translate 4 units down. So this would go 90 degrees to the right and 4 units down. And remember, just to kind of get an idea for where we're going with this, this is a sine curve, okay? So if I wanted to draw this curve, I would have to transform these points right here. 0, 0, 90, 1, 180, 0, 270, -1, 360, 0. And I would transform them by making a mapping rule. And that's what we're going to do in the next video. Okay, remember the connection between the vertical translation, or the k value, and the equation of the sinusoidal axis. It's a horizontal line, has the equation y equals, and it's always equal to your k value. So note the connection. little a and the amplitude. Well, the amplitude is absolute little a. There's a connection between the b value and the period. H is kind of on its own here, the phase shift or the horizontal translation. And there's a connection between the vertical translation and the equation of the sinusoidal axis. I'll do one more example, and then you can try the worksheet or these questions from the textbook. So for this guy, I'm going to add 5 to both sides. You can try this, pause the video and try this on your own first, okay? And then I'll, when you unpause it, you can kind of follow along and see how you made out. So if I add 5 to both sides, I end up with y divided by 2 equal to -4 times the cosine of 3x minus 90 degrees. And this would become a -2, -7 plus 5. Now, I am going to get rid of the divide by 2, I'm going to multiply by 2. Keep in mind, I'll do the same thing. Remember in the last example, I divided the a and the k by 2. So when I multiply, same thing's going to happen. I'm going to multiply the a and the k by 2. So this would leave me with a y equal to -8 cos. And I'm going to do this right now. Okay, I'm going to factor out the 3. 3x divided by 3 leaves x. -90 divided by 3 leaves -30. Close the brackets twice. And then don't forget to multiply this -2 by that 2 here. So now it is in standard form. I can see that my a value is -8. I can see that my b value is 3. I can see that my h value is -30 degrees, and I can see my k value is -4. Now, if you had to describe the transformations, here's what you'd say. Okay, just like chapter 1, 2, 7, and 8. That function is vertically stretched about the x-axis by a factor of 8. The negative indicates that it's also vertically reflected in the x-axis. The function is horizontally stretched about the y-axis, or compressed would be a better word, by a factor of 1/3. Remember, it's the reciprocal of your b value. There is no horizontal reflection in the y-axis because this is a positive. It is translated 30 degrees to the left and 4 units down. Okay? You can try the worksheet as well as these questions from the text. It's just about putting your equations in standard form and picking out your parameters. I believe on the worksheet they also ask for the equation of the sinusoidal axis and the period as well, and the amplitude. So not just a, b, h, and k, these other 3 things as well. Good luck.